Okay, so today we're going to talk about the day 2 of confidence intervals. We've already discussed a little bit about confidence intervals and what it really means. We said that the lower that our confidence was, the tighter the interval, the greater that our confidence was, the wider the interval underneath the normal distribution. And so then we also started talking about the 68, 95, 99.7 rule. And we said we put out 1, 2, and 3 standard deviations. And we said that 2 standard deviations away from the mean, using that rule, is 95%, captures 95% of the population, or the area underneath the curve. So we have 5% left over, and we divide that in half, and we get 2.5% on each one of the tails of the normal distribution. But in reality, these that are our estimates, the 68, 95, 99.7 rule. And so what we'd like to be is a little more accurate. So if we looked at the A table, so if you went over and you checked out 0.025 in your A table in the front of the book, using the Yates, Moore, and Starnes, then you would see that that z-score that corresponded to that was negative 1.96. Also, if you went over and you looked at the upper 0.025 or 2.5%, which is going to be 97.5% to the left, you're going to see that the z-score is positive 1.96. And it was agreed upon a long time ago that we would use those upper tail positive values, all right, as our z-stars or our z-scores when we're calculating confidence intervals. So if you happen to get the negative number, if you're looking at the lower one, just go ahead and make it the positive. So if you had 5% on each tail, you can look up the lower left one and just make it positive. Okay, but so it's going to be given to you. You'll find that those resources are readily available almost all of the time. So you want to remember that z star is the upper tail critical value, that probability underneath the standard normal curve. Okay, and it's also in table C in the back of the book, and it's reflected in the diagram at the top of that page. There are 3 z values or z scores that we use most often. That's 90, 95, and 99%. 90 represents the middle 90%, so you have 5% on each tail, and the z star is 1.645. 95%, 2.5% on each tail. Z star is 1.96. And then at the confidence level of 99%, you have 1% left over, so that's 0.5% on each tail. And that Z star that you would use is 2.576. While we'll use some of the other ones, these are the ones that are most frequently used in our book, and the other ones are readily available. If you had 80% or something else, you can find those. It's not difficult to look in the back or the front of the book. Now, a confidence interval, we want to make sure that we remember that we're using that confidence interval to estimate a parameter. So when we look at the formula for confidence interval, we see that it's x bar plus or minus z star and then times sigma over square root of n. Right now we're being given sigma, which is a parameter, right, which is the population standard deviation, and very shortly we're going to move away from that because ideally we're not going to know that one either. You're going to get your x bar, you're going to be given a set of data, put it in a list, go to one variable stats, and then you'll be able to get your x bar, and very soon we'll use that standard deviation that you get from there also. But for now, we're given the population standard deviation, and we'll move on with that. Now, for the 4-step inference toolbox, remember other books have different steps to it, some of them as many as 10, but ours combines it down to just 4 steps. And if we look at this, the first one is to identify the population of interest and the parameter that you want to draw the conclusions about. Okay, so you got to be very careful about that. Identify the population. Where did you pull your sample from, and what are you measuring? What's going to be in the last statement? If you can't identify this in step 1, the chances are you're going to get it wrong in step 4 because you're not going to state your answer properly. Now, next one, step 2, choose the appropriate inference procedure. Well, the only thing you know how to do right now is confidence intervals. So you're going to say, step 2, confidence intervals for means. When we get 2%, you'll have to specify it that way. Verify the conditions for using the selected procedures. Well, we've been talking about these goofy rules of thumb that we've had, which we're the only ones in the world that are going to know what those are because they're in our book, not everybody else's. But the first one we have to make sure is that in order for us to be able to use the standard deviation, okay, we have to make sure that it's normally distributed. Okay, so is the population, well, actually, let's check. Is population greater than 10 times the sample size? Always make sure that you're checking that. And since we're using means this time, you're not going to be using the NP is greater than or equal to 10, because remember, that's for percents, that's for proportions. For means, we have to it's got to be given to us. We'll either graph it, maybe on a stem and leaf plot to see if it looks normal, Or if the n is greater than 30 by the central limit theorem, we're going to assume that it's normally distributed. Another thing you want to check in step 2 was it random? Is it a simple random sample or a random sample? And if it's not, you have to say proceed with caution, because we don't know. That really could mess up our results. Step 3, if the conditions are met, then you're going to go ahead and carry out the inference procedure, and you're going to say the confidence interval is your x bar plus or minus your margin of error. And we'll also learn how to do that on the calculator. And then step 4, you're going to interpret your results in the context of the problem. You're going to say, I am 95% confident that the true mean of this particular problem, and make sure you put context in it, is this, and then between these two numbers, and then make sure that you use units if possible on it. And most of the time it is possible. Okay, so here are the 4 steps. Identify the population parameter you are investigating, the conditions, do we have biased data, is it random or not? If it's not, or you're not sure, you always got to proceed with caution, and we're abbreviating that PwC, but please, on the AP test, don't abbreviate it PwC. You'll get docked points. Just put proceed with caution. Do we have an independent sampling? Alright, if the population is greater than 10 times n, we're good. Otherwise, we have to say proceed with caution. Is it a normal distribution? Okay, so remember that the population that's greater than 10 times n, that allows us to modify the standard deviation. Okay, so that's what that first one is. And I really hate using the rule of thumb 1 and 2, but if that helps you identify it, then that's great. So if the population is 10 times greater than n, we can modify the standard deviation. And that particular rule is for both proportions and means. Now for means, we're testing if it's normal, and then n has to be greater than 30 for the central limit theorem, or we can take and graph it to see if the stem and leaf plot is roughly normal, and then I'll also show you how to do it on your calculator to see if it's roughly normally distributed on that one. Okay, or look for in the problem. Very often it says that it's normally distributed. Otherwise, proceed with caution and go on to step 3. Okay, step 3. Find a z-star based on your confidence level. Okay, if you're not given a confidence level, our default level is 95%. Then calculate the confidence interval. If you're using your calculator, make sure you put the formula down and fill in all of the values. And underneath the formula, you put use calculator. Otherwise, the answer you get manually may be different from what you get from a calculator, and College Board will deduct points for that. Then finally, step 4, it's the interpretation of your solution. And you're going to say, I am 95% confident, 90% confident, whatever it happens to be. That's a true mean in the context of the problem is between this and this, and then refer to your units. Simple as that. 4 straightforward procedures, and you're going to have a nice, clean problem when you're done. Here's an example. Let's take this. A random sample of 50 Florin High School students was taken, and their mean SAT score was 1250. Now, we're going to assume that the population standard deviation is 105. So what is a 95% confidence interval for the mean SAT scores for Florin High School students? Well, first, step 1, population and parameter. Okay, Florin High School students. Then the parameter we're measuring was SAT scores. The procedures and conditions, the confidence interval, the population is greater than 10 times the sample size. Yes. Is it normally distributed? N is greater than 30, so we can assume normality by that. One thing it doesn't say on this one, we need to proceed with caution, is that it doesn't say if, it does say it was random sample, so we're good with that. Okay, so it's a random sample, so we can proceed from there. So it's normal, population is 10 times greater than sample size, it's a confidence interval, and it was random, so we can go on to step 3. The z-star, the upper tail probability for a 95% is 1.96, and we've seen that several times. We need to modify our standard deviation by our sample size of 50, so you want to make sure that it's 105 divided by the square root of 50. So our confidence interval looks like this. It's 1250, that's our mean, plus or minus 1.96, we got that from the 95% confidence interval, over the standard deviation is divided by the sample size. And we get 1220.90 and 1279.10. You want to make sure that you don't flip those around, all right? Because it's as you would see them on a number line, they're numerically increasing. So make sure that you report them as that. Now, step 4, interpret your results. We are 95% confident that the true mean SAT scores for Florin High School students is captured in the interval between 1220.9 and 1279.1, and you're done. I hope this helps you. If you have any questions, come see me later. And if you have any suggestions on how to make this better, please let me know. Thank you.